You know, sometimes I think about how crazy it is that we can learn about these like super tiny particles, you know?
Oh, yeah.
It's mind-blowing. And today, we are going to be diving deep into one of those neutrinos.
Awesome.
They're these subatomic particles, so tiny that they're basically ghosts.
Right.
And they're just constantly zipping through us, through the Earth, through everything.
It's wild.
And get this, China is about to finish this incredible project. It's called the Jiangmen Underground Neutrino Observatory, Juno for short.
Yeah.
To figure out the secrets of these like crazy elusive particles.
It's a big one.
Our guide for this deep dive is an article called China's Giant Underground Orb.
Catchy.
And trust me, the name is pretty accurate.
Yeah. So what I think is so fascinating about this project is just the scale of it.
Yeah.
You got to imagine this giant transparent sphere, 35.4 meters in diameter.
So wait, hold on. 35.4 meters. Are we talking like 12 stories tall?
You got it. 12 stories tall, underground, 700 meters below the surface.
That is insane.
It really is. I mean, just thinking about all the engineering challenges they had to overcome to build something that massive and also that delicate that far down is amazing.
Yeah. The article mentions it's made of this like super thin acrylic shell.
Right.
It's only 12 centimeters thick.
Yeah.
I mean, that doesn't seem like a lot when you think about all that pressure from the Earth on top of it, you know?
It's a testament to how clever the design of this thing is. Proportionally, that shell is as thin as an eggshell.
Wow.
But it holds back the weight of all that Earth, plus 20,000 tons of this special liquid called alkylbenzene.
Alkylbenzene.
Yeah, which is like crucial for detecting these neutrinos.
Okay, hold on. I'm going to need you to break that down for me a bit.
Sure.
Alkylbenzene, what is that?
Okay, so alkylbenzene, think of it as like a giant super sensitive detector.
Okay.
So when a neutrino, just by chance, interacts with an atom in the liquid, it makes this tiny little flash of light. And Juno is built to pick up on those super faint signals, which, believe me, is no easy feat.
Right.
It's tricky.
So to be clear, they built this gigantic, super sensitive underground orb to try and catch these little flashes of light from neutrinos.
Exactly.
That is pretty wild.
It is. And it's taken a while. They started construction on Juno back in 2015, and they're hoping to have it fully up and running sometime in 2025. So we're looking at almost a decade of dedication to try and unlock the secrets of these particles. It really shows you what kind of commitment you need for big scientific breakthroughs.
It does. But like, why go through all this trouble? What makes these neutrinos so special? What secrets are they holding on to?
So neutrinos are like the ultimate cosmic messengers.
Oh.
They come from some of the most extreme places in the universe, like the cores of stars, supernova explosions.
Really?
Even the Big Bang itself.
Whoa. So they're like little time capsules?
Pretty much.
Carrying information from billions of years ago?
Yeah. And because they interact so rarely with anything, they travel through the universe almost completely undisturbed.
Wow.
So they're bringing a perfect record of those events.
That's incredible.
It is. Yeah, it really is amazing.
So it's more than just catching these little ghosts, right?
Right.
It's about decoding those messages they carry.
Exactly.
Like, what kind of information are we talking about here? What can they tell us?
Well, one of the big mysteries Juno is trying to solve is something called the neutrino mass hierarchy.
Neutrino mass hierarchy.
Yeah.
Okay, break that down for me. What does that even mean?
Basically, it means figuring out the order of the masses of the 3 different types of neutrinos.
Hold on, 3 different types.
Yep.
Is that like flavors of ice cream or something? Are there strawberry neutrinos and chocolate neutrinos?
Yeah. Not quite, but it's a good analogy. Think of it this way. Electron, muon, and tau neutrinos each weigh a little bit differently. And figuring out which one is the lightest and which one is the heaviest has some really big consequences for our understanding of physics.
Okay, I'm listening. How does knowing which neutrino is the chunkiest help us understand the universe?
It's a big clue to solving one of the biggest mysteries in physics. Why there's so much more matter than antimatter in the universe.
Antimatter, huh? Like the stuff they use in Star Trek.
Kind of. It's basically the opposite of regular matter, and when they meet, they annihilate each other.
So, like, if there was the same amount of matter and antimatter, they would have just canceled each other out, and, like, nothing would exist.
Exactly. But, I mean, we're here, obviously, which means something tipped the scales in favor of matter, and figuring out the neutrino mass hierarchy could be the key to figuring out how that happened.
Wow, so these little particles have a lot riding on them, huh? What else can JNO teach us?
Another big goal is to get really, really precise measurements of neutrino properties. It's about fine-tuning our understanding of how these things work.
So are we picturing scientists with tiny little calipers trying to measure a neutrino?
Haha, well, not exactly. It's a huge challenge, but Juno is designed to get those measurements with incredible accuracy. And that data is going to be essential for testing and refining our theories of particle physics.
So we're talking about like rewriting the physics textbooks. That's pretty huge.
Yeah, it really has the potential to revolutionize our understanding of how the universe works, at its most fundamental level.
Yeah, so far we've been talking about neutrinos in the sun and other stars, but the article also mentioned something called geoneutrinos. What are those?
So geoneutrinos are neutrinos that come from the radioactive decay of elements inside the Earth itself.
Oh, wow.
They're like messengers from deep inside our planet, giving us a way to study the Earth's interior that we've never had before.
So it's like getting an X-ray of the Earth, but with neutrinos instead of radiation. What can they tell us about our planet?
By looking at geoneutrinos, we can learn about what the Earth is made of, like the composition and how those radioactive elements are spread out inside the Earth. And that tells us a lot about things like how heat flows through the Earth, the movement of tectonic plates, even how the Earth formed billions of years ago.
It's pretty mind-blowing to think that these tiny particles that can pass through entire planets could also help us understand the ground we're standing on.
It really shows you how everything is connected, from the tiniest subatomic particles to the biggest things out there.
It really does. This is all so fascinating. But I have to ask, what does this all mean for me? For someone who's not a physicist or a neutrino expert, why should I care about these discoveries?
That's a great question. Yeah, it's a really good question. I mean, it's easy to feel disconnected from these big science projects.
Totally.
Like it's all happening in some other world or something. But honestly, scientific discoveries, even the ones that seem really abstract at first, they have a way of rippling out and changing our lives in big ways.
I see what you mean.
Think about electricity, right?
Yeah.
I mean, it used to be this totally theoretical thing that people were trying to figure out, and then bam!
Yeah.
Light bulbs, smartphone.
Our entire world changed.
Exactly. Or our understanding of atoms.
Mm-hmm.
That led to nuclear energy, which I know has its issues, but it could be a source of clean energy for the planet.
So you're saying even though we may not see the immediate use for something like neutrino research, it could have big implications later on.
Exactly. I mean, we're just starting to understand neutrinos, so who knows what the future holds?
Yeah.
Maybe someday we'll be able to use them for communication or energy production.
Or something we haven't even thought of yet.
Exactly.
It's like we're opening this door to a whole new world of possibilities. We have no clue what we might find. And that's pretty exciting.
Mm-hmm.
And even beyond the possible tech stuff, there's something pretty profound about just understanding the universe, don't you think?
I totally agree. It speaks to our curiosity, as humans, that drive to explore and make sense of the world.
Yeah.
These discoveries, they kind of belong to all of us, right?
Mm-hmm.
They're part of our shared story, our quest to figure out the universe and our place in it.
I love that. We're all on this grand cosmic adventure.
Totally.
And Juno, with its mission to find these little ghostly particles, is taking us one step further.
And speaking of Juno, I was really struck by the fact that it's a global effort.
Yeah.
You've got scientists from all over the world working together on this project.
It's a real testament to how powerful international collaboration can be in science. I mean, these huge projects need so much resources, expertise, different perspectives. It takes a global village to pull it off. Absolutely.
Yeah.
It's a good reminder that even with all our differences, we can come together, to learn and understand.
It really gives you hope for the future.
It does. It shows that science can bring people together, beyond borders in our search for knowledge.
It's powerful stuff.
Well, this has been an incredible deep dive into the world of neutrinos and the amazing Juno project. I feel like we've only just scratched the surface here, but it's definitely left me with a sense of awe and wonder.
I feel that. And that's what's so cool about science, right? Every time we discover something new, it opens up more avenues to explore, more questions to ask, more mysteries to unravel.
And that makes it a never-ending journey.
It really does.
On that note, we want to thank you for joining us for this deep dive. We hope you've enjoyed exploring the world of neutrinos and the incredible Juno project. Until next time, keep looking up, keep asking questions, and never stop exploring.